Well, good morning or good afternoon, depending upon where you're viewing from. I would like to welcome everyone to the virtual planes today for a discussion on cyber-informed engineering. Real privilege to have a number of the principals involved in this effort, as well as many others who are responsible for implementing some of these solutions. We'll hear from President Chris Roberts in a little bit, but we're going to start with a Q&A with Joyce Carell. And Joyce and I have been on a couple of journeys together, including serving on the executive group for DOE and the cyber-informed engineering effort, but also through the Cyber Solarium Commission. And I can tell you without a doubt, Joyce is a leading voice and a leading light on so many of these issues. So Joyce, real privilege to have you here today. And before we jump right into the discussion around cyber-informed engineering, I thought it would be good to put this into context a little bit. And there are a number of cyber-related strategies out there, and I was hoping you could sort of put this into context. So Joyce, your thoughts would be great.
Good morning, good afternoon. Thank you. Thank you for inviting me to this. And thanks, of course, to Auburn for hosting this event. This event was long in the making, so very pleased to be here. My name is Joyce Carell. I'm the Senior Technology Advisor for the National Cyber Director in the Office of the National Cyber Director in the Executive Office of the President. ONCD is the newest organization in the White House, and it's been in existence slightly over a year. It was created through legislation that was one of the Cyber Solarium Commission recommendations about a little over a year ago. Currently, we're about 56 people strong right now, a startup operation, but this is so we're very much at our early stage, growing pains to some extent. I like to joke and tell people that my first job title was actually employee number 6. So you asked about, we worked together on the panel for the cyber engineering, the executive task force that actually led to the development of this strategy. So that was a great opportunity where there were a whole variety of stakeholders that were in that. It was senior and technical experts from government, from industry, from academia. The DOE National Labs were plugged in. So very robust set of experts, bringing together and advancing, taking the work that Idaho National Labs had launched a few years ago and putting it up at the strategic, the national level. So, that's definitely an achievement that the Department of Energy should be very proud of. You asked the question about different strategies and how should this strategy, fit into some of the other works that are going on at the national level. Certainly, I think everyone has seen, the White House is very concerned about cybersecurity, and this particular administration has reached a threshold in demands on industry to produce products that are cyber secure or that have been developed through secure means. And through government procurement, we're going to demand that things the government buys, that companies have to produce artifacts to demonstrate that they were produced through secure development processes, and they've been tested, and that the functionality is resilient. And I think that entire concept of secure by design, which the CIE strategy is advancing, fits nicely into that. And those actions were out of Executive Order 14028 that was published by the Biden administration back in, I think, February last year. More recently, the administration also issued an executive order on America's supply chains, 14017, and looking at the energy sector or the energy industrial base was one of those. So this is a good time in which to launch this strategy and see it be taken up by the energy industrial base. But right now, as a nation, we lack a number of, we have a number of openings in cybersecurity jobs. Not just jobs, there are a core set of jobs that are for actual cyber professionals. Those are the people who do incident response, who run networks, who develop capabilities. We have the last statistics I have heard is that there are approximately 700,000 vacancies at the national level, not just in government, but in the private sector as well. So with all these vacancies, the importance of educational institutions or training and accreditation institutions, baking in many of the core principles outlined in this strategy to get to secure by design and resilient systems. Achieving resiliency is a priority for the National Cyber Director. That'll be a theme that we look and exercise over the rest of this year and into other years. So I think that sort of answers your question a little bit on other strategies. We're working on a workforce strategy. And that's we had hosted a summit about a month ago, bringing together senior leaders from industry, from training institutions. We included, the Secretary of Homeland Security, Secretary of Commerce, as well as, senior leadership, Secretary of Labor, Susan Rice, to kick off this and to demonstrate the level of priority that we are placing on the national cyber workforce education. And what is coming out of this particular strategy, the framework outlined in the strategy, is going to feed directly into that.
Awesome. Thank you, Joyce. And I might underscore that, and I don't want to put you in an awkward spot, but ONCD is coming up with a national strategy as well, which all these pieces will hopefully fit into. I'd be curious. So the NDAA and Congress directed that the cyber-informed engineering strategy be focused on the energy sector, but do you see broader impact for a number of the principles and findings of the report itself?
Absolutely. Just looking at those sectors that ride on industrial control systems, the water sector, now more the transportation sector, the advanced manufacturing, or even when we look at new construction of facilities, building automation, the principles outlined here are very applicable to all of those areas as well. And I would say that we're finally at a point where, as a government, as a nation, when we look at cybersecurity, we shouldn't just be thinking about cybersecurity in the. We should change the way we speak about this, and instead of just talking about cybersecurity in the context of IT and communications, and then separately in some other silo talking about operational technology, we should group these all together and look at the core principles of these in a systemic manner. And when you look at these other businesses as well, they're becoming increasingly automated. And as they plug into the industrial Internet of Things, they having baked in security from the very beginning will be vital to managing the risk and exposure. And as well. There's more connectivity and more automation. So I think the time is right for us to, take this particular body of work to the next level.
And briefly, one more question, because the tyranny of time require I'd be a bit of a tyrant since we're running out of time. But what is it going to take to translate the nouns into verbs or the concepts into reality here?
I think one of the first steps that we should take in, we had a great set of stakeholders, key participants in the executive task force, but that was a limited set of stakeholders on a very congressionally directed outlines, left-right barriers. But I think now we need to broaden the aperture and bring into the fold a broader set of stakeholders to then of the different steps outlined within the strategy. Begin to build those areas out more with the broader set of stakeholders. One of the key things that the National Cyber Director, Chris Inglis, likes to foot stomp and emphasize on a fairly routine basis is from where he is at the White House and the effort that went into creating this new organization. A key driver was to achieve unity of purpose. So this particular strategy helps pull us in a direction at a fast pace, given all the hard work that has been done to develop these best practices. And from a Another important element is how important public-private partnerships are to actually having effective cybersecurity. So how we think that through will be top of the mind going forward.
Awesome. Well, Joyce, thank you for joining us today. Thank you for your service inside the national security community for so many years, and thank you for continuing to advance these issues now in the Executive Office of the President through NCD, which I think we all want to see succeed, and having good folks like you make that much more likely. So thank you, Joyce, and thank you for spending some time with us and putting CIE into context. I now have the privilege to introduce my boss, the president of Auburn University, who, but prior to becoming president, was dean of the College of Engineering. And let me say, Chris is the reason I am at Auburn University. He's a rock star. And more importantly, I think you're going to hear from everyone. CIE is a conceptually important set of issues, but if you don't have executive leadership, it's just a good idea. Dr. Roberts has taken this good idea, run with it, and I'm just privileged to be able to work with him. So Dr. Roberts, President Roberts, the floor is over to you. Thank you, sir.
Frank, I really appreciate the opportunity to make a few remarks today, and Auburn University is exceedingly proud to be engaged in this session, this important discussion. I thank you all for joining today to discuss a topic that's frankly very near and dear to my heart. It was the reason we recruited Frank to join us here at Auburn. Cyber-informed engineering, or CIE for short, is extremely important. And in my prior role as Dean of Engineering here at Auburn, for many years, my team and I worked to try to elevate cybersecurity policy, education, and research as a priority in our efforts. And in my current position as president of Auburn University, I've had the good fortune of being able to support that priority in an even greater and broader context. And so it's really a delight to welcome everyone to this forum, which will hone in on the recently released strategy from the U.S. Department of Energy on CIE that Auburn was very proud to play a role in. And I say that with a great deal of enthusiasm. The university at large and the McCrary Institute for Cyber and Critical Infrastructure Security is particularly honored to have representatives of the national laboratories, industry, and government with us today. And we have a phenomenal group of leaders participating that are super excited to hear from through today's sessions. Auburn's an amazing university with tremendous potential for greatness, and together we can advance the awareness and knowledge of CIE throughout our nation to truly make a difference. And I'm sure that you're aware of the cyber workforce deficit that we have. It was recently discussed in that White House summit, and it was noted that there are about 700,000 jobs that are short in the industry, putting into perspective just how integral cyber has become in everyone's business. And Auburn begins to make strides to be part of that solution. We wish to help drive some of that solution, and we know that we're in good company with others that are wanting to do the same. Universities have an opportunity and a responsibility to educate the next generation and our workforce, and to address some of the pressing challenges coming that are facing our country. And so we're really thrilled to have so many great students and faculty members who are enthusiastic to contribute their time and their expertise to this important cause. There's no shortage of challenges to tackle, but the type of collaboration that we have here today will stand us in good stead moving forward. And we hope to be able to continue and deepen our dialogue and partnership with each of you. It means a lot to us to have this opportunity. Frank, on behalf of the university, thank you for organizing this session and for engaging these just truly impressive people. Enjoy the program, and as we say here on the plains at Auburn University, War Eagle. And Frank, you take it from here.
Dr. Roberts, thank you, and War Eagle. So thank you for joining us today. And I think it goes unsaid that having presidential leadership at a university on matters such as this is integral. So thank you for your leadership. Thank you for your support. And thank you for all you do. So thank you, sir. And What I want to do now is we sort of put into context, let's get down to the strategy itself. And I think to start with that, we want to hear from the director of CSER, Piyush Kumar, who's a longtime advocate on cyber-related issues, knows the industry inside and out, and really thrilled to have had the opportunity to work with you, Piyush. So maybe as an opening question, start framing the strategy itself. And I'm going to have a common question for everyone on why now, what needs to be done, and obviously its significance. So Piyush, maybe you can open us up by just giving us the context of the overall strategy.
Great. Thanks so much, Frank, and thanks to Auburn University's McCrary Institute for hosting this really important conversation today. So let me add my thanks on behalf of the Department of Energy for your leadership, Frank, and of course Auburn for really bringing us together and also contributing to the development of the cyber-informed engineering strategy, along with the many other things, Frank, that you've been involved in, such as the Cyberspace Layering Commission. Those are all really important efforts that are helping really drive progress in the cyber security space from a national level. And you heard it from Joyce, and you're going to hear it from others on the panel today, that these are really important issues. And I can tell you that this is an issue that the administration is taking very seriously, and we're trying to tackle it from a lot of different perspectives. And today we're going to be talking about this one that is very important, which is cyber-informed engineering. Also, let me just quickly recognize our Securing Energy Infrastructure Executive Task Force. So this was the task force that we established as DOE to bring together different groups of folks together to actually really develop the strategy and work on other items related to really securing energy infrastructure. Certainly some of these things we're going to be talking about can be applied to other critical infrastructure sectors. So I'd encourage folks from other sectors to take a look at it as well. And last but not least, I want to recognize our colleagues and friends at Idaho National Laboratory, who are really a lot of that driving force behind the conversations we're having on cyber-informed engineering. They were pioneering this effort in other sectors and really starting to think about how do we apply this to energy and then even much more broadly. So Zach, who's on the going to be on the screen in a minute, thank you for your leadership and your team's work in this space. So with that, let me dig into this strategy a little bit. From our vantage point at DOE, the strategy brings together a broad base of energy system developers, manufacturers, standards organizations, academia, national laboratories, and owners and operators of the infrastructure. It brings us together to really think about security by design. This is one of our priorities in CSER, is to really start to build in security by design into everything we're doing, from ideation to deployment. We need to ensure that security is just as core of a component in the energy sector as is reliability, safety, and efficiency. And so this is one of the ways we really need to tackle this. With that said, I expect some of you are thinking, this isn't necessarily a new strategy. And you're right. This is something we have been talking about for a very long time. But what's different now is we actually have a strategy. We have a plan, and this is where we need to get together and coalesce around the plan to actually put it into action. And we're going to need leaders such as the president from Auburn University. We need leaders at the White House such as Joyce and my friend and colleague Sherry Caddy, who you'll hear from later today, who are all coming together to say we're all going to take part in this and we're going to help move the ball forward in this specific thing. And so we're really hoping that the cyber-informed engineering strategy will be a place to bring folks together and start to drive action going forward. Now, if you take a look at the strategy, it's really built on 5 big pillars. The first pillar is awareness. So really starting to bring awareness of the CIE or cyber-informed engineering approach. It's bringing that awareness to not only owners and operators of critical infrastructure, but also systems engineers, manufacturers, researchers, standards organizations. And we need to really get that awareness that this is a shift we are going to make, and we're going to make it very consciously. We're going to actually look at our standards and how we design things with the lens of cybersecurity. And so that's kind of where we are right now. And that's why meetings like this and engagements like this are really important, because we need to raise that awareness across the board. And what we're seeing from the DOE end is there's a lot of interest in this, and that's very exciting. And that strategy is helping us build that awareness. Number two, we need education. So the idea here is to embed CIE into formal education, training, and credentialing. We can't effectively implement CIE without also preparing the workforce to implement its principles throughout the energy infrastructure ecosystem, certainly, from the DOE perspective, but also more broadly from critical infrastructure and all the systems that we're operating. And we really need to do that through that education. Number three, we're looking at development. So we want to mature CIE approaches and promote broad application by building a repository of tools, practices, methodologies that practitioners can draw upon and really start to apply it to existing and new infrastructure that exists across the United States. And then number four, we're focused on the current infrastructure because we recognize that there's a lot of infrastructure that's already out there. And how do we start to apply these principles of CIE into that infrastructure? Because we know it's going to be there, and so we have to address it. We have to ensure that we can start chipping away at some of the infrastructure that's already there and start to embed some of the CIE principles into it. And then number five, and that's looking at the future infrastructure and really starting to build in security into what is going to be the infrastructure of the future. And within the energy sector, this is the time to do it. We are making historic investments in the energy sector. If you saw the infrastructure bill from last year, the IIJA, or the bipartisan infrastructure law, and then most recently, the Inflation Reduction Act, a lot of that is focused on energy infrastructure in the United States. And so we have a strategic opportunity to really build in security into the electric infrastructure, energy infrastructure of the future. And this is when we need to start doing it. So this is the perfect time to get engaged and really start to drive us forward. The Secretary of Energy, Secretary Granholm, has said it that we can do both. We can build a clean energy infrastructure of the future that can also be secure. We can do both things at the same time. And so that's why we're excited about it at DOE. And we recognize that we can't do it alone, though. We need partners. We need partners at the national labs, in academia, with manufacturers, and with owners and operators, and standards organizations and others. So with that, Frank, I hope that framed the overarching strategy well. I look forward to the discussion.
Awesome. Thank you, Piyush. And thank you for covering so much territory in a short amount of time. That was spot on. And I can't help but think safe, secure, better. And thank you for your leadership in ensuring that. Next, we're going to turn to Zach Tudor, who was also part of the Securing Energy Executive Task Force. But I think more importantly, Piyush highlighted, INL has been doing CIE before it was cool, and Zach in particular is the coolest of all. So, Zach, you want to maybe frame a little bit in terms of where you see things now, and the question I ask, and we'll ask the same of Stan, is literally, why now? Why is it significant? Why now? What do we need to do? So, Zach, maybe hone in on a pillar that you're interested in, and I turn it over to you, sir.
Yeah, great, Frank. Thanks so much, and Piyush, thank you so much. Thanks for all the work that you and the Department of Energy have done in this, and also we'll be thanking Sherry, who was spearheading that executive task force through the time, and for making this important to the Secretary, so that way we actually got this national strategy signed. So Frank, to your question, why now? I think it's also tied to why the energy sector. And I think it's because the sector is ready. The asset owners, we have Southern Company here, others, the vendors, the integrators, academia, and government, understand that now is the time to really approach this secure by design type of effort to make our critical infrastructure, our energy infrastructure, more secure, but also lead the way for other infrastructures. I also want to mention that, besides cyber-informed engineering, consequence-driven cyber-informed engineering that focus on systems, that for a long time we've been trying to battle the secure software lifecycle, and so there have been efforts in those areas as well, and they are not going to go away. they are part of secure systems, and we have to remember that that's another foundation that we have to build and mature as well. So things like the software development lifecycle that Microsoft had, build security in, building code for building code, have all been different types of methodologies or programs that have been talked about for software. And I think we haven't really focused on systems as much in that security because we were focusing on that IT infrastructure, and the servers, let's say, themselves were not particularly the attack vector because they ran software. It was important. Cyber physical systems, our OT systems, they have hard impacts on the things that we do every day, whether it's creating energy, distributing it, helping our planes fly, cars that are getting smarter and smarter, driving infrastructure. They are all impactful in a different way than those software-driven systems. But the software is still tremendously important. But we have to remember that the hardware systems that we're talking about now for cyber-informed engineering are really impactful in a very different way. So here at Idaho National Lab, we've been looking at this, as you mentioned, for quite a long time. And through an internal investment at the lab, some researchers looked at the way new reactor systems are designed and started the concept of cyber-informed engineering. And we've been building on that. CIE for current systems, for legacy systems, we call that consequence-driven cyber-informed engineering. And that was kind of the first thing that I think got traction. And people started pointing to, well, what's the root of that consequence-driven thing, that cyber-informed engineering, and DoD and the NDAA, and asked the Department of Energy to bring all of us together in that area. It was a great effort, but it's just the beginning, and I'm looking forward to the discussion, but also the work that needs to be done.
Thank you, Zach, and certainly not last, but certainly not least, we're going to hear from Stan Connolly. And we've talked about public-private partnerships for as long as I can remember, but it always historically was a little bit of government lead, private sector follow. I've got to say, when it comes to Southern Company and when it comes to this sector in particular, I think we flipped it a little bit. And in all reality, Southern has been on the forefront, leading so many efforts around cybersecurity. So Stan, and I don't mean to be pejorative, I'm in a university, but this is more than just an academic exercise, isn't it? And I'd be curious how Southern is sort of leaning forward and taking the ideas and making them real.
Yeah. Well, look, Frank, thank you. I appreciate those comments. But look, I'd say to my colleagues on this panel, it feels like we're kind of in the same huddle, using a football analogy here. Who's your team? You've been great partners with us on so many ways. And Zach, I mean, you hosted our chairman yesterday to have some critical conversations around this. So look, there are so many legs to this stool, and I'll do my best to represent the owner-operator side of this, the practitioner in some ways, if you will. But look, why is this important? Look, our industry, and it's been said already, our industry is going through this transformation, both on how we make, move, and sell our product. Southern Company is in 7 states. We serve 9 million customers, both electric and gas operations. We're also national in that we offer microgrid solutions to a number of customers directly and other utilities like ourselves. And this transformation's been happening for a number of years, but as has been mentioned already, there's certainly some larger motivating factors that have recently come to bear. The infrastructure bill we talked about, the Inflation Reduction Act, and the tools that are in that for us to continue this transformation. But look, you go to the other end of the line, our customers are expecting us to make this transformation successful for them. And building into this, the culture of cybersecurity into our organization and into that of the partnerships we form, we just think is quite simply a part of the safe, clean, reliable, affordable mission we have for our customers. They're counting on us to get this right. And there's so many changes in the threat vectors that are out there. There's so many changes in the OT systems that we deploy to deliver energy to our consumers. There really is no time better than the front end of the work we do to build into all that the cybersecurity philosophies that I think CIE is trying to promote here. Maybe said another way, CIE is playing great offense to build the right defenses. And I think that may be a good way of thinking about this, being on the front end where we can, the energy transformation and infrastructure build out we've got ahead of us, done right through building in the cybersecurity thoughts and protections. I think we'll do all the right things for our customers. Look, if I could quickly, I may reframe the 5 pillars a little bit into kind of an internal view for our company, maybe a partner view with our company, and then lastly, building the next generation of cybersecurity experts. Look, I think there's so much we can still do. We've been working hard for a number of years to build awareness, to build specific training and tools for the men and women who work at Southern Company today, to continue building out that culture of cybersecurity. We'll continue to do that, and I know CIE will introduce new ways of thinking of that for us. And we look forward to working with this group moving forward as we build all that out. But we're also building the next generation of men and women who will deliver for our customers. And I think about working with Auburn University. I think about working with the IBEW in our apprentice training programs. I think about working with the HBCUs or, the institutes that build skilled technicians. I think there's really critical work we can embed into those curriculum, if you will, those training activities to build that future workforce so that they're better prepared tomorrow to come to work for companies like Southern Company or our peers in the industry and continue building out this culture of cybersecurity. I think that's a really important thing we need to focus on here. I really look forward to working with Frank, you, and others to build that out more robustly under the framework that we've offered here under CIE. But I'd also say working with partners. I was thinking about the role of groups like EPRI, and I'm fortunate I get to serve on the board of EPRI right now. And we talk about building cybersecurity into every research component of their portfolio as we move forward. So it's designed in the R&D stage, then it's built out through the designs we have with partners like Schweitzer. You're going to have them on a panel a little bit later. They've been incredible partners to us at Southern and the industry, thinking innovatively today about the products we're going to install. Zach mentioned hardware. I think that's so right. Thinking about how we're going to install the protections in the hardware while we're also thinking about redesigning and replacing our legacy operating systems. So, look, I think CIE has so many relevant ways it touches our business today. The really exciting thing for me personally, and it's been a pleasure to be a part of this executive group working on this, is how we build out the framework for what comes tomorrow. There's so many changes that are coming. Our own company has a net zero target. Many in our industry have done the same, whether it's the electricity production, the delivery systems for our electric and gas companies, or right up to the meter and the services we provide to customer homes and businesses. This cyber work we're doing touches all of that. And I think the only way for us to be successful is to come together and collaborate like we've done here. And I think this is a great start that we can build on.
Hey, Stan, thank you. That was awesome. I'm reminded of Yogi Berra, who said the future ain't what it used to be. The reality is, if you want to predict the future, you shape it. And I don't want to oversimplify things here, but it is a cultural thing. It's an education thing. It's a technology thing. But in the end, it's really a people thing. So I'm really happy you underscored the importance of the workforce. And whereas technology will change, human nature remains consistent. Let's go on offense so we can improve our defense, as you said. And when we talk partnerships, and I think this is important, there's a lot of discussion around what makes a good partnership. I kind of boil it down to 2 things: trust, in the words of Samuel Clemens or Mark Twain, trust is the coin of the realm. And give and take. If you have a lot of taking and no giving, and a lot of giving and no taking, that's not a partnership. So I think figuring out how we can get into the foxhole collectively to get things done is the way to do it. So thank you for that. Piyush, I'm going to give you the last word before I turn it over to Zach and his amazing panel. Anything you'd like to leave us with, and thank you again for for your leadership at DOE to make sure this is not just, again, I'm at a university, but it's not just academic.
No, I appreciate that, Frank, and I couldn't agree more with everything that Stan and Zach have talked about. The only other thing I'd add is, a lot is changing with the energy sector, as Stan just talked about and did so well about the energy transition. We're seeing customer requirements changing. We're seeing technology changing to make the grid more reliable and more resilient. While all of those things are happening, the reality is we're also seeing the threat changing. And so this is more important than ever before, where we are seeing cyber threats, cyber adversaries targeting the US energy sector. And this has been talked about in the Director of National Intelligence's Worldwide Threat Assessment. And so we have to do this. There's no other option. And so we have to really start thinking about this, because this is where the threat is today. But where is it going to be 5 years from now, 10 years from now? And so we need to start making these investments today. And that's why this is so important. So thank you again for your leadership, Frank, and Auburn University's leadership on convening this dialogue today.
Well, Piyush, thank you, and thank you for this sobering reminder. We can't get this wrong. So thank you for that, and thank you to Stan and Zach. And Zach, it's going to be over to you with your panel. So thank you, and onward and upward.
I'm hoping that we'll be able to kick off in a moment. Well, welcome back. Thank you so much for joining us. We really enjoyed the initial discussions with the president of Auburn University, Frank Salufo from the McCrary Institute, Piyush Kumar, and others. But right now, I have an excellent panel to talk about making the case for cyber-informed engineering. I think that's something that we started in that other panel, but we can continue it. So joining me will be Sherry Caddy from the Office of the National Cyber Director and the former Senior Advisor for Cybersecurity at the U.S. Department of Energy. Mo Khalil, he's the Associate Laboratory Director for National Security Services at Oak Ridge National Laboratory. Donald Sullivan, the Global Director of Security Programs at Los Alamos National Laboratory. Vail Oxford, Director for Global Security Strategy at Savannah River National Laboratory and the former Director of the Defense Threat Reduction Agency. And Stephen Taylor, Associate Dean for Research at Auburn University. So I'm going to start with Mo first, and we were talking earlier in the sessions, about the energy sector going first in this kind of cyber-informed engineering pathway, led through the executive task force that was convened by DOE. But there are other sectors, there are other needs here, and I know, Mo, that you're familiar with many of them, and you could give us your perceptions of what other things need to be done besides just the energy sector.
Sure thing. Thank you, Zach. So I think one of the important sectors is actually the manufacturing sector. And especially, if we start to look at Industry 4.0 and digital manufacturing. In the United States, clearly we need to onshore manufacturing and we need to increase the productivity. And to do that, we need to democratize manufacturing, and especially to look at emerging technologies in manufacturing. One of these technologies actually is additive manufacturing, and another is subtractive, which is really machining. A lot of these tools, depend on data, they depend on software tools, and also industrial control systems. The factories of the future will connect actually multiple machines together. And so you have also communication protocols, communication layers among these machines. So one of the big issue, I believe, is related to supply chain security. And that's where cyber-informed engineering comes into play. That is, we need to do a lot more verification of the data that we get, the software tools that we get, and also the machines that we have. Furthermore, a lot of people, when you democratize manufacturing, they're not really familiar with the control systems and things of that nature. So if something got attacked or something, you really need to be able to swap things, fairly rapidly from there. Now, we as a country and as a community, if we want to democratize manufacturing, we need to create an architecture that actually helps ensure that we can continuously monitor these machines and understand what's happening with them. So we need some new software layers that actually help us with that. But the attack vector for these machines can be huge. There is more than, I'm going to say, 30,000 machining shops in the United States. So just imagine that. If you digitize all of that, then we have a lot of issues. Now, as we go forward, I would believe, some of these tools will be used to manufacture things broadly for the entire economy, but also for defense type manufacturing. And there we need to ensure that actually the materials we're getting are the materials we want, that we design things for. So I think a lot of that is really needed. One thing I would like to say quickly, it's actually, if you look at emerging technologies, we all know we need data to control the electrical grid, to do the communication and control of the electrical grid. So as data becomes more, dominant and we rely more on it, clearly we need to advance our communication and use different tools. One of these tools that we use is a quantum encryption keys. And these are tools that you use, the communication tools that actually help you distribute random number generators. But the random number generators are not really generated on quantum machines. They're rather generated on traditional machines. And these traditional machines can be attacked. So an area of cyber-informed engineering is really to understand the vulnerabilities that we have at the interfaces of a quantum and traditional computing, since we're generating these numbers on traditional computing. So really there is a need here, again, to do some studies on smaller systems before we go actually generalize this on the larger, say, computers and networks of that nature. And there's a lot one can talk about in terms of emerging technologies, 5G and the Internet of Things, and the need for cyber-informed engineering. But I'll stop right here, Zach.
Yeah, thanks, Mo. And we do have a large representation from national labs, and you highlighted how the labs can make an interesting problem even more interesting. Cyber-informed engineering is something that we have been working on with partners. The other thing I also want to mention is we're not alone. I think I mentioned earlier that we've really been focusing on software for the longest time, because most of the meaningful attacks that we'd seen across the U.S. and across the world had been software-driven attacks on software systems, databases full of personally identifiable information, or banking systems. In the recent history, we've seen more impactful attacks against critical infrastructure, both around the world and here in the U.S. And cyber-informed engineering, particularly for energy sector, to answer Frank Salufo's why now, why energy, is kind of that reason. It is now top of mind and people understand. Next, I want to turn to Don O'Sullivan. Don, can you give us the perspective that you see there at Los Alamos?
Yeah, so it's a really important area that we need to focus on in terms of understanding the pace of change in the technology. So when you're talking about infrastructure in general, and most engineered systems, they're intended to exist for many years, if not decades. But the technology that is running them, or that is connecting them to the rest of the system, becomes obsolescent within a couple of years. And so I think one of the big challenges we have to figure out is how we develop modularity into the system so that you can upgrade the technology that is running the systems, that is communicating with the systems at a pace that makes sense for the system that's being run. Obviously, building infrastructure, critical infrastructure, those systems are designed to exist for many years. And too often what happens is they become legacy systems, right? So they're installed, often by the time they're built, the technology that's running them is obsolete. And so we need to figure out how to manage our procurement cycle and our procurement aspects of implementing these systems such that they can be updated at a pace that makes sense, and that becomes part of the procurement contract itself, so that you're not just buying a system that sits by itself, but you're buying a service with it that allows it to be modernized continuously.
I think that's a really important point to make, is that with cyber-informed engineering, we hope not only to make systems that are secure today, but securable in the future, with those capabilities that allow us to use new techniques to add that inform that resilience and risk reduction. And we'll talk about that more later. But when we talk about risk reduction, I think being able to turn over to Vail Oxford is the perfect time there at Savannah River, but also from the ditcher perspective.
Thanks, Zach. Good afternoon, everybody. One of the things that I want to do is go back to kind of the strategic layer, then dive down a little bit more. I got to Ditcher just at the time that the Secretary put out his national defense strategy that for the first time in 15 years really guided our efforts against our major adversaries. While we managed terrorism, it was a matter of getting after Russia, China, Iran, DPRK. And as we started to look into that, and without going into a lot of detail today, we recognized within many of their war plans, especially China, the first phase of any conflict is going to be a massive cyber attack. So that gave us the impetus to start looking at ways to mitigate this. From my vantage point, we lose status in the world if we're not able to flow forces, those kinds of things. But CIE comes at this right at the right time when you think about the question you asked, Zach, what other sectors are important to this. The defense sector since 9/11 has been worried about their reliance on the commercial grid. And so when you think about the dependence there, a cyber attack that allows us or prevents us from flowing forces is critical. So as I look at the problem and start to dive down, we also need to think about how we launch a major national initiative like this. I had the opportunity to try that at DHS when I was asked to stand up the Domestic Nuclear Detection Office, which was an interagency office designed to counter nuclear terrorism for President Bush. We really had to think hard about how to bring the state, local, federal, and private sector together. It's a hard lift. And so as we think about the implementation plan that would follow CIE, we really need to think about how we implement this, who we engage. And the sticking point in many cases has been how do federal entities, to include national labs, who are kind of a quasi-federal entity, deal with the private sector. There's a lot of rules and regulations that were put in place to protect each other from each other. And now it's a time where we need to be more jointly dependent. So really breaking down those bridges and figuring out how to bridge the gap between that and as well as the other entities, I think is critically important. When we think about the pillar that is education, that's going to be a long haul. When Savannah River National Lab was rebid, Battelle bid a 5-partner university consortium that's part of our alliance. And in discussions with Mo and others, we have a lot of regional partners. They don't change their curriculum overnight. There's got to be a constant demand in education that goes with that. And I've already sent notes out to all of our university partners to ask them to start thinking about how they would do this. But from a national perspective, that drumbeat's got to be constant, it's got to be loud, and somehow incentivize the universities who worry about where their students go, what they're going to do when they graduate. If you turn the clock back after 9/11, we were ill prepared to deal with the bio threat. By the time we reversed the activities at our universities, we saturated the market with bio experts who couldn't find jobs. So we need to think about some of the elements that Mo just talked about in terms of the pursuits people are going to go into and why this has to couple with the threats of the future. And I think that makes a compelling reason for some of these students to really, really dig into some things that are just not a traditional mechanical engineering field, for example, but coupled with the manufacturing of the future. So I think one of the other questions is, the continued expansion of interconnected systems also gives a larger attack platform and surface for adversaries to go after. So we've got to be constantly doing what was just talked about in terms of refreshing capabilities and technologies. It cannot be static. It's got to be dynamic. And finally, I would just mention one thing specifically at Savannah River that is an opportunity. That is, we operate actual nuclear facilities, and the ability to start building some of this into our new pit production facility, those kind of things, give us an opportunity to do it for real in a case that matters for the nuclear deterrent. So I'll stop there, but I think CIE is coming on board just at the right time. There's a lot of work to be had.
Bill, thanks so much. And it was also gratifying to see, we mentioned that one of the kind of pillars here for CIE is consequence-driven cyber-informed engineering. We talk about that for legacy systems, and the fact that the NNSA has brought on teams to teach CCE to people within the nuclear workforce there is very helpful. But you mentioned so much about the workforce and about education systems, so that leads right into Steve.
Thank you. Thank you. So obviously, I'm at a university. I'm at an engineering college with several thousand engineering students. So my comments are going to be offered from the perspective of in my role right now as interim dean, somebody that's responsible for graduating competent engineers and computer scientists. And so here at Auburn, we have a saying that we strive to be the best student-centered engineering experience in America. We want to provide rich learning experiences for our students, but fundamental to that is we're going to graduate competent engineers. And so in today's setting, when you look at the problem set that's posed to us when those engineering graduates go out into the workforce, it's really hard to argue that the concept that really every one of those engineering graduates should have some competence in cybersecurity and understand cybersecurity principles. Today, for years, when we have our seniors present their senior capstone design project at the end of their experience, we typically will challenge them and have them say, have them address what are the safety issues with your design, what might be environmental issues with your design, and how have you addressed those? How have you changed your design to mitigate a safety concern that you had? I think going forward, we probably should expect the same set of senior engineering students to be able to respond and say, these are the cybersecurity concerns that we have with this design that we encountered, and here's how we changed our design to mitigate those, or here's how we address those. I really think going forward, we need to treat cybersecurity just like we traditionally have treated safety and other concerns in the education of that student and in their preparation to go into the engineering workforce. So the cyber-informed engineering strategy to me is timely. It certainly resonates with those of us in the engineering leadership here at Auburn. Recently, following the White House Summit on Cyber Workforce and Education, our university leadership stated a commitment to incorporate the cyber-informed engineering strategy across our engineering and computer science programs. We take that very seriously. That will be a process. That's a consensus building process where we start with the leadership, but work through the faculty and our academic programs to develop a common understanding and a common appreciation of why we're doing this and then how do we implement this. And each program may implement it in a different way. We may have different strategies throughout our curriculum, throughout that 4 or 5 years that the student is here. We'll find ways to do that. But I think consensus building is a critical part of that inside the university. But then I think what's critical is to carry that forward outside the university. The strategy talks about credentialing. It talks about ABET accreditation, incorporating criteria related to the strategy, or even eventually influencing the FE exam or the PE exam. And so all of those are processes that in most cases, they start here at the university where we begin to make changes in our academic programs, but then we influence our professional societies. And the various engineering professional societies are really the ones that drive the criteria that ABET adopts and ultimately the exam questions that are in the PE exam or the FE exam. So I think it's a consensus building process that starts here where we decide, yes, this is important to us. We feel like, again, every engineering graduate should know these concepts. And then we work to influence the community around us, our professional society, the accrediting bodies, the credentialing agencies. And so it's timely. The concept, I don't think you can argue with it in today's environment. And so we hope here at Auburn that we will become a leader in this, that we will be a leader in adopting this technology and hopefully sharing the curriculum ideas with our peers around the nation. So I'll conclude there.
Hey, well, thanks so much. You hit on a bunch of interesting points there. I particularly like the part about credentialing, but we'll hopefully get back to some of those. And last in this round, Sherry Caddy. And so I don't know whether you were the driver or the engine of the Securing Energy Infrastructure Task Force or of our things here going on with CIE while you were at Energy, but I feel that you'll probably be either an engine or a driver in your new role there at the Office of the National Cyber Director. I also I've made sure that I stayed away from some of the key points that I hope that you're going to make right now. So please, Sherry, give us your perspective.
Thanks, Zach, and great to be with this panel and just listen to the different perspectives on cyber-informed engineering, and how many people are really engaged and see their role in this, and that's really so critical. And certainly in my new role at the Office of the National Cyber Director as a senior advisor, being able to bring in those multifaceted perspectives and really elevate what has been a fantastic idea. Kudos to Idaho National Labs for really, coming up with the foundational concepts that have evolved into this national cyber-informed engineering strategy, and getting certainly the Department of Energy, the energy sector coalesced around this idea. And this is a great example of how we've been able to take some really good ideas, bubble them up to a critical sector where they can be applied. We can be the pointy end of the spear in applying these concepts for the energy sector industrial base, but then also being able to pull them up to the national level. And I'm really looking forward to being able to do that because, as many of the speakers here have noted, we're really not just looking at critical infrastructure in isolation. Energy systems are connected to water systems, to transportation, to all number of types of systems. So we really need to think about this broadly. And when we think about security by design and really how to do that, we have to engage in this multi-sector, multifaceted community to really get to cyber. Cyber crosscuts everything, and that is the wonderful and terrible thing about cyber is it's in absolutely everything. So really, now that we've published this strategy, being able to open that aperture and bring in all of the different stakeholders that we need to make meaningful progress, and that's progress through that public-private partnership that some of the speakers have highlighted, progress through multi-sector, multidisciplinary. Just everybody has a role here, and it's wonderful to listen to the speakers that have been assembled today, that they already see themselves in this strategy. So we're making a lot of headway, and as we bring in and engage that broader set of stakeholders who want to work with us on the issues that we've identified here, from education, training, awareness, to looking at what the R&D needs are, to looking at how to apply this to current legacy, often long-standing infrastructure, and then in particular new infrastructure, new technology. So many different types of stakeholders need to come together. So we want to coalesce the coalition of the willing around what are the high priorities, what can we do collectively, how can we really move the needle on both achieving security by design, which we've been talking about for a long time, but also getting to, I think, dare I say, an underserved community for cybersecurity, and that's the engineering community. And as speakers have noted, there's a very strong culture of security that's developed in the engineering community over the past several decades, so that safety is something that engineers think about reflexively as they design, build, and maintain systems. So how do we take best practices, lessons learned from that experience, and help this community in developing that culture of security, so that reflexively engineers, all kinds of engineers, think about it. It's part of education. It's part of training. It's part of certification. We have standards that support it. We have use cases all up and down the line to help this particular community really understand, realize, and implement cybersecurity in a way that is so critical for the nation. So this is a really fantastic opportunity. The timeliness is there. The stakeholders are there, and it's really exciting to be a part of it.
Thanks, Sherry. And then one thing, I tell people, and it was discussed earlier, so the concept that we need to build security in or be secure by design is not new. So in that aspect, this is just kind of a follow-on, building on a foundation that has been kind of aspirational for so many years. What is new is that it has been adopted by not only that coalition of the willing, as you mentioned, Sherry, but also kind of a coalition of the responsible. Those of us that make systems, those of us that secure systems or that deliver energy, understand that we need to do better and needed that organizing principle. So CIE is not a methodology for engineering cybersecurity and systems. It is an action plan, or we're going to become a call to action, and the following action plan that will say, here's how we recommend you include cyber in the waterfall model, or in your spiral model, or in the new model that you're going to develop. Here's some of the tools that we can develop to make sure that cyber-informed engineering, that the artifacts from the design phase, make it through to the delivery phase when we talk about security and things of that nature. I know I really liked when Don was talking about that modularity. Don, could you talk a little bit more about that? How can we make systems in the future more securable by that type of design?
Yeah, I think we have to change our mindset in terms of when we're developing a system. Traditionally in engineering, you are thinking about how that system is going to function from more of a mechanical perspective or electrical perspective, and you don't generally think about the information incorporation and how that's managed. And so the tendency is to assume that the technology you have available today is going to be sufficient for the future use of that implementation. And I think we have to think about it as an evolving system. Yes, there are going to be many components of the system that you're going to want to implement that are going to be enduring. And it would be not cost effective to plan your infrastructure development on the timelines that technology evolves. So you have to figure out how to coalesce those two different types of systems, one an information system that evolves rapidly, and a more enduring physical system that hopefully will last for a much longer time. And just in the same way that CIE is an evolving mindset, trying to think about how you build in security at the outset, the same is true for enduring systems that you want to incorporate technology into. It used to be you're just thinking about the functionality, but it has definitely grown. And one of the big steps we're taking with CIE is just raising awareness so that people can think about how, when they implement a new system, how do they make sure that the underlying technology that's going to support that system can evolve in an appropriate way. And so what are the service models that are needed? What are the skill sets that you want to bring to that design? I think too often we think about technology as having some sort of separate organization that's going to work on that. And, you're going to have your traditional engineering people work on, and they need to be integrated. And so the more we can integrate those systems and those thought processes and have those people think about how they're going to develop what they need for the future, the better off we're going to be.
Hey, thanks so much, Don. So Mo, as you mentioned before, and I know that Oak Ridge, besides in their own right, having some of the most advanced manufacturing capabilities for next generation manufacturing, are a key player in what's called the Cyber Manufacturing Innovation Institute, where some of these concepts that Don was just talking about, are being applied, and cyber-informed engineering is something that's being applied in that area as well. Although I disagree sometimes, because I'm one of those that doesn't necessarily believe in composability. So making a secure system out of secure components, but I can tell you, you can't make a secure system out of insecure components. So talk a little bit about how you see manufacturing and what that institute is doing and what Oak Ridge is doing about next generation manufacturing as we think about it for cyber-informed engineering.
So I think the CyMan Institute actually is hitting multiple fronts. One of them is the Institute is working with over 65 companies. And also, we have a large number of universities and 3 national labs and the Idaho and Oak Ridge. And so when it comes to workforce development, the leading institute, University of Texas at San Antonio, is actually a minority serving institute. And they're trying to bake cybersecurity into their curricula, which I think is really, really important. Right now, when I think about cyber-informed engineering, I tend to think about a holistic approach that we have for cybersecurity, and baked into it actually is mitigation strategies. And so, like when we as engineers, when we design, if you're a mechanical engineer, you design something, you tend to think about failure modes, okay? And you're trying to say, okay, how would this system fail? I think, in cybersecurity, we need to think about, the vulnerabilities and what are the vulnerability modes, and we need to design these systems for that. And so that's one of the things we're trying to do really in the area of manufacturing. But at the same time, as I said earlier, I believe, digital manufacturing will be will be widely spread across the sectors. So you need really a new thinking in terms of software layers that can actually help you in continuously understanding the situation of your machines and detecting these threats. A lot of times we tend to think about AI as, artificial intelligence as the silver bullet that actually solves all problems. In reality, AI layers are actually fairly vulnerable, right? So we need resilient AI layers, for manufacturing and other things, but we need adaptable AI layers that can actually adapt, like other colleagues mentioned, because we tend to think about the threats of yesterday, and so we need to think about the threats of today and the threats of tomorrow. So that's really what the SciMani is really trying to do on all of these fronts, and trying to test the advancements in the carbon fiber technology facility here at Oak Ridge, or in the advanced manufacturing facility, the demonstration manufacturing facility here at Oak Ridge.
Okay, thanks a lot, Mo. Vail, as you mentioned, they're now at the Savannah River, and you mentioned the university consortium that you have there, and how you're working with them. I don't know that a lot of people that aren't in national labs know much about the way we work with universities in that way, along with the other partners that we have across the nation. Can you fill a little bit of that in, and talk about how you work with them?
Thanks for that. One of the things people on the video today may not recognize is we stood up as an independent national laboratory June 21st, 2021. So we're essentially DOE's newest independent FFRDC. So when Battelle bid the contract that ties together with the University of Georgia, Georgia Tech, Clemson, South Carolina, and South Carolina State. So we started off naturally with workforce development. What were the demand signals for the students that would be coming out of those institutions, and internships, joint internships, all those kind of things that, in fact, we're in discussions with Mo right now about having people share the experiences working at both of our national labs, just so they understand the differences, and that try to bring them into the workforce long term. But when you've gone to one college and a university, you've gone to one college. So it's also a matter of figuring out where you have to go to really start talking to the people that are the experts in the fields. And when you say cyber, you naturally end up in like the computer science, as opposed to going over to mechanical or other engineering. So I think this is going to allow us to flatten some of those activities, but also to educate people on what the needs of the future are. Everybody says cyber, and everybody immediately says, well, it's highly competitive, it's hard to hire people. That's just the way it's going to be, and we're doing this with open eyes, that they're going to be pulled away periodically, as we used to say when I was at PNNL. They may get hired by industry, and then when they get beat to death by being a number in industry, they'll come back home and do something tangible. So I think that's one of the benefits of the national laboratories, is having that mission-driven kind of focus that represents DOE as well as the rest of the interagency and some of the pursuits that we have. So I look at some of these things as having a regional footprint. We're kind of properly placed in locations that will benefit this initiative long term by having a presence. We get to know people, and then my recommendations to Sherry and others is to create some kind of oversight steering group that would bring together the key stakeholders, maintain as she said, best practices that are coming from different locations, and sharing those best practices elsewhere. Because we cannot do this as a national initiative. It's going to have to be more localized to deal with the governors, the mayors, the stakeholders like utilities in each of the regions to make progress. And I think, one of the good and bads of our government, it can change every 4 to 8 years. And anytime something new like this starts, you want to show forward momentum quickly and be able to defend the needs in the future. So it's the politics always have this, but I think, the National Guard, for example, is a really big factor within our region. They have 2 cyber battalions. And so they are, they're civilian soldiers. So they go back to work in their locations, and they take this knowledge back with them. So universities, the National Guard, all provide opportunities to expand the awareness of what CIE is trying to do. But as we've already said, with Auburn, they're looking for embracing it, but it's going to take a while to really truly adopt it. But we've got to start now. I think this is a very good start, and we'll take the lessons learned from today. And again, I've already sent this out to the research associates at our 5 universities to start the dialogue.
Hey, thanks so much. And you do mention a lot of the things that drive us here at the National Lab. that regional influence, but also, national impact is big as well. Dean Taylor, a couple of things I heard, throughout this were kind of a change in mindset. Mo said something about new thinking. I also know that Sherry likes to talk about raising the required daily allowance of cyber for engineers. Talk a little bit more about, you're very modest when you mentioned, that you were going to be putting competent engineers out there. We know that you develop excellent engineers, but talk about some of that new thinking, that mindsets, and how you're going to inculcate that in those graduates.
Yeah, great question. Really tough, really tough problem too, by the way. But just to change, you all know, to change an organization, to change multiple academic programs, it will be challenging. But certainly, we're able to reach freshman engineering students when they come in the door. We put them into design experiences very early on, and so there's an opportunity as freshmen to begin to socialize the concept that, hey, it's not just the traditional engineering constraints that we've always responded to. There are others. Cyber is an additional one of those. So we're able to potentially do that at the freshman level, and then throughout the curriculum, there are opportunities to introduce that again, and build complexity, build competence as you go through the curriculum, and then obviously culminate in a senior design experience that again might expect those students to understand those concepts and have addressed them in their design projects. So throughout the sophomore or junior year, there's probably going to be opportunities to weave that into other experiences. Some of their if you're a mechanical engineer, or electrical engineer, or aerospace engineer, yes, there's not a lot of room to add new computer science courses, but there are places where you can incorporate additional cybersecurity topics in some of the programming courses that they already take, or simulation courses that they take. Another suggestion that's been floated, we have what we would refer to here as an accelerated bachelor's master's pathway, where students can begin taking graduate courses as an undergraduate, and then they get credit for those if they want to stay and work on a master's degree, and that accelerates their master's program to potentially a year and a half master program. And so we could offer a pathway for students in a discipline like mechanical engineering to have a few cyber preparatory courses that would then prepare them to do a master's in cybersecurity engineering. And so that graduate would leave with a bachelor's mechanical, a very good foundation in mechanical, and then a master's in a cybersecurity engineering degree. So those are some ideas there. Again, I think the idea to start students early and begin that understanding of cyber as a freshman, repeat those topics throughout the curriculum, and potentially even offer these 3+2 or accelerated bachelor's master's types of programs are some of the ideas that we've talked about so far.
Hey, well, thanks. And let me tell you that I know that the folks here that represent national labs, earlier we heard Stan Connolly from Southern Company. We're going to be looking for those types of students when we have internships and when we follow on. So hopefully we'll help reinforce that change that you're trying to make. So in the time we have left, Sherry, I wanted to give you the final word and let you kind of wrap it up for us before we move out.
Thanks, Zach, and thanks to all of the panelists today. I really am totally energized by the great ideas that folks have expressed today, and really energized by having our national labs, really the heart and soul of our federal research and development enterprise, really involved in cyber-informed engineering. This is there's such force multipliers in this space, as some of the commenters indicated. It's where multiple universities come together. It's where multiple federal agencies come together between the Department of Energy, the Department of Defense, Homeland Security. All of us, use the national labs as our research engine. The connection with industry partners as well. So having that core
focal point really is going to help us get to that broader community. It's really necessary to move the needle on both bringing more cybersecurity to engineers and that culture of security for engineers every point in their development life cycle, as well as really generating that federal unity of effort to really achieve security by design. We've all been talking about it. We know we want it. We know we need it. How do we really identify some key priorities as a community that we can go after and really advance the state of the practice? And again, having the labs, having all of these partners fulsomely engaged, having the mojo that comes from national level attention from the White House, I think we're really poised to make significant gains in this area. So I'm really excited and really thankful for the partnership of all of you, the Department of Energy, and everyone involved here today, and so much more to come. Thanks.
Well, thanks so much. And I would like to thank the panel, Sherry Caddy, Mo Khalil, Donald Sullivan, Dale Oxford, and Steve Taylor. Once again, thank you so much for your participation. This is the beginning, but it's a very auspicious beginning. So thank you very much.
Thank you.
Well, thank you, Zach, and thanks to the panel for such insightful thoughts in terms of making the case for cyber-informed engineering. We now have the opportunity to hear from some of the brightest minds on making it real, basically pathways forward, and how we can translate some of these concepts into capabilities and how we can actually implement these ideas into action. And couldn't ask for a better group than Jeff Baumgartner at Berkshire Hathaway Energy, Mark Bristow at MITRE, Casey Carnes at the Tennessee Valley Association, or TVA, James Gooseby at Southern Company, and I might also be Senior Fellow of the McCrary Institute, Mark Sachs of the McCrary Institute, and served on a couple of the technical committees for the drafting of the strategy. And last but certainly not least, Nick Seeley with Schweitzer Engineering Laboratories. So what I thought I'd do, because it's a big group and we got a lot to cover and not a whole lot of time to do it, is open with framing questions and let the panelists jump in. For round one, we will go alphabetically, or not, alphabetically, and start with Jeff. But in terms of the question that I thought to frame is what are some of the leading efforts in the energy and other critical sectors to integrate resilience into OT? Because when you look at CIE, it's an opportunity to finally realize how OT, IT, physical and cyber can be better integrated. Another question, if you'd prefer to jump into, is how CIE can be applied to bolster or accelerate these efforts. And finally, any CIE principles that are being put into practice already today. So Jeff, why don't we start with you? Then we'll go to Mark, KC, and down the line. So Jeff, over to you.
Yeah, thanks, Frank. I think I'll probably hop around a little bit. So internally, we actually do have a implementation of sorts of CIE that we run through a resilience process to really understand the threats, measure the risk from those threats, and then adjust either our policies, procedures, or add technology to better manage that risk and validate those resilience actions through drills and exercises. So that's kind of our implementation of CIE at a 100,000 foot level. But as far as the private sector goes, I think there are several good opportunities to integrate this work in operational collaborations like DHS and CISA's Joint Cyber Defense Collaborative, or in the DOE as the management agency. building out some of the energy threat analysis center capabilities. How do we incorporate the concepts and the frameworks in CIE into those processes so that when we identify gaps in our defenses or vulnerabilities or threats, creating complete solutions, not just for current infrastructure, but future infrastructure, and getting that out into a public domain to be able to be adopted by vendors, manufacturers, and utilities alike.
Thank you, Jeff. Mark, anything come top of mind to you here?
Yeah, Frank, and thanks for having me on the panel today. I really think that, and in deference to my colleagues here that work at asset owner operators every day, I think they have a really big challenge ahead of them, and that's how to prioritize like what actually matters, right? When it comes to investment of cybersecurity resources, or how you're improving your resiliency, and understanding where the actual impacts can occur are absolutely critical to identifying where we should be investing our resources. And that's a hard problem to solve right now, and it's one that I think we need to work hard to make easier, right? And have better resources, not only available at every individual asset owner operator, but better resources more broadly that can apply, as Jeff mentioned, to the whole community, and really understanding what actually matters to the safe, reliable operations of your process. How can you remove that cyber risk with maybe some different engineering choices as you're refitting or fielding new technologies into the environment? And then ultimately, we're trying to deliver services to the public in many of these instances, and certainly with the power companies that are represented here. And so it's a national imperative that we get this right. And it's a hard problem. And I think, by working together and identifying and coming up with ways to prioritize where we should actually be focusing that, and that partnership is where I think that we'll get the most bang for our buck. And I think the current industry is a little focused on a lot of some compliance regimes and those types of things that ultimately don't drive down that impact. And really getting to the place where we're actually mitigating risk is where we need to get to, as opposed to just making sure that we're checking boxes.
Mark, thank you for that. And I'm reminded the old adage, what gets measured gets done, but are we actually measuring what matters? And what's so complex here is it's a hard science and a soft science. I mean, the reality is we need to bring them both together. KC, sort of from a TVA owner operator perspective, what are your thoughts?
Yeah, I think the principles that should be put into practice today are, if they aren't there or you haven't thought about them, you should be. Because I mean, this is where we got to get to. We really got to get to that, secure information architecture, planned resilience with, the no assumed security, which is zero trust. I joke a little bit. I'm gonna go figure that one out because I have an executive order that says that I must. So I'm all over that. Also, with our small modular reactor at Clinch River coming, that's going to be a place we're going to go dig in and leverage these kind of principles and ideas and figure out how to, truly design out a lot of that security opportunity and risk. And, getting in those layered designs and focusing across the supply chain is really a broad area that impacts all of our business operations, no matter where it is in our function. So I think that's really where we have to lean in. And I think you'll see there are people out there leaning in. There's some past efforts, like with Coyote and things like that, where groups have come forward. But I think we need to do more of that at every layer.
Thank you, Casey. And I'm glad you brought in design out or engineer out cyber, or you could say bake in and integrate in. I think spot on. James, I mean, we heard from Stan earlier, and he clearly rang the bell and made the case, and Southern is leaning forward. So I know you've been engaged personally, not only in the CIE strategy, but also integrating some of the IT/OT entities collectively within Southern to get full visibility. So curious what your thoughts are.
Yes, thanks, Frank. I appreciate the opportunity today. Well, when you think about these assets that we are putting on the ground and the changing energy landscape, we're living in a more connected world. And so at Southern Company, one of the things that we realize is that you think about customer groups and then your traditional plant operations. You have your power delivery groups, and then you have your traditional IT groups. Well, those groups today have to partner together. And so you think about it as that internal ring. So within any organization, CIE is a mechanism to give us a strategy that it lets us have a view of north. So what are we trying to get to, and what are we looking to achieve? What problems are we trying to solve? And so in this world, we have a number of work practices and standards and procedures today that actually align with CIE. For example, if you think about electromechanical systems that will trip a boiler offline if you lose the control system. Well, that's an example of implementations that we within Southern and other organizations have in place today. And that's through NFPA regulations and requirements. And so one of the things that we've had to step back and think about is, well, we need to educate and create awareness around CIE within our ecosystem of team members within Southern Company. And so you think about technical training groups. Most organizations have a technical training group. So leveraging those existing resources within your organization and start to build out that knowledge base. And you have to be broad because this is a multidisciplinary approach that CIE brings to the table. I mentioned electromechanical systems. So you can't say this is all about digital and we're only going to target those folks that are working on digital control systems or industrial control systems. We also have to think about the mechanical systems that are coming into play. We have to think about those vendors that we're sourcing these systems from. They're multidisciplinary, integrators, EPC contractors. And in this new world, as you think about net zero and this drive toward net zero, now we're getting into distributed energy resources, where traditionally, when I first came to Southern Company, I could work at a power plant, and within Southern, we managed all of those assets, and we didn't have a lot of outside interaction in regards to our designs and our procedures and work practices. But today, we're buying solar sites from developers. We have behind the meter assets are being put in place. And then and we have a need for visibility into those behind the meter assets. We may not even own those assets. We might operate those assets or maintain them. So for me, CIE is really become something that we have embraced and will continue to embrace. And as we think internally about our, as I mentioned earlier, technical training organization, our engineering organizations, all these organizations within our operating areas that need to be aware and also need to be partners with us internally and also our external partners and having a meaningful, intentional approach to the path forward.
Awesome. Thank you, James. And I do want to pick up on you highlighted the importance of suppliers and manufacturing, and we have a great provider there in terms of Schweitzer, and I hope Nick can touch on some of those issues. But what I get from what you said is it is a way of doing things. It's a way of doing business. It's a way of life, and it's a way of operation. So all good things. Mark, I mean, you've been engaged and involved in the strategy from the get-go. So what jumps to you first of mind?
Yeah, thank you, Frank, and thanks again for pulling us all together. This is a really great opportunity today to put the word out. The team worked for about a year and a half to bring the strategy together, and so now the opportunity to launch it, let everybody know about it, is excellent. Most universities, engineering schools, the students that come in, of course, are coming from local communities. And one of the areas that we are going to focus on, of course, is local community resilience. So an engineer comes in, learns civil, learns mechanical. They may go off to a big company someplace, but many go right back home and can conserve their communities. So if you think about the hidden infrastructure inside of communities and the resilience that needs to be there, many communities are well prepared for weather events. Be they northern tier with snow and ice, or southern tier with tornadoes and hurricanes, or perhaps earthquakes. Cyber introduces a new peril that we're all going to be aware of. And so these engineers, as they begin to learn about and applying the principles of CIE, can bring them back to their communities and now be a bit more prepared and a bit more ready for the new types of threats that we're beginning to see And hopefully we can avoid situations where cities get hit with ransomware or utilities get shut down or other things that put life and safety at risk of the citizens there. So it really becomes a community resiliency effort as well as an infrastructure resiliency effort. So thanks, Frank, and I look forward to continuing this effort. We are not done, even though the strategy's out. There's still more work to be done.
True that, and I'm glad you underscored communities and state, local, tribal, territorial, because when you look at this issue, even above the energy lens, I mean that's the weakest link right now nationally, and business as usual just ain't going to cut it. So we have to come up with new ways to be able to implement solutions. So thank you for that. Nick, I mean, as at Schweitzer, and you guys are obviously on the forward leaning edge in terms of OT technologies, manufacturing. So I'd be curious what comes to mind to you first.
Yeah, thank you, Frank. A lot of what comes to mind for me is just that we are working a lot with integrated systems, right? I mean, that's all we do anymore, and with IoT, IIoT, all those things, like that's really where things are going. So we need to focus on that. And when we talk about resiliency, how do we make sure that some failure in one area is not necessarily going to bring down somewhere else, right? So we want to make sure that systems work collectively, but they also function independently as well. And we've seen examples of that, right? We've seen an example of where, say, an attack on an IT system caused like just a preemptive shutdown of the OT system. The attack didn't affect the OT system, but just out of pure caution, like they wanted to shut everything down just to make sure that it couldn't propagate over there. And that's the kind of example of things that we're really trying to avoid. And I think where things like CIE could help us make sure that we are, what we talk a lot about at SCL here is, like, we like to say communicate more but rely on it less. So from that perspective, we've got a lot to think about, and that's a technology system too, right? So we also can think of, and you mentioned supply chain. Supply chain is unbelievably interconnected. And I mean, just for example, maybe I think people generally know that, but one thing we learned earlier, this year, I can't remember exactly whenever the Russian incursion over in Ukraine was. Turns out Ukraine supplies 25% of neon gas to the world, and you think to yourself, well, that's great. Why are neon signs so important? But it turns out that neon is actually really important for the fabrication of semiconductors, right? Which, I mean, who knew that? Like that, and so a lot of us are understanding and starting to figure out and getting a master class in global supply chain management as we're going through all of these other things, through the pandemic, through the Ukrainian invasion and things like that. So it's really, that's what we're thinking about is how to make sure that we are resilient in the face of all these things. The electric power system ran just fine without any sort of cyber anything for probably the first 100 years. So it was generally a fairly resilient system. So we want to make sure, as we're adding these technologies, we're able to maintain that resiliency, but also get the benefits from all of what this technology has to offer. So that's really what we're thinking about.
I'm really happy you brought up the broader supply chain issues and in the context of Russia and Ukraine, but obviously you've got in the Pacific Rim, you've got Taiwan and obviously the massive dependence the United States and the entire world has on, from an economic security standpoint, chips and manufacturing. And I think all these issues really are front and center now, things that we thought about but didn't have to worry about. But the reality is we see how fragile some of these single point failures can be. And really important to start thinking about that again before it's too late. And I want to start with you, and then I'm going to sort of go around. But from a manufacturing standpoint, how is SCL getting its arms around this? Because you brought up a very important point. And the reality is as new technologies are integrated, it expands an attack surface. But there is also an opportunity to sort of from a systems design and engineering standpoint to try to get as far left of boom as possible. So I'd be curious what some of your thinking is there and how SEL, how significant SEL thinks that is.
Yeah, so I guess where I can go with it, on the theoretical level, one of the things, and somewhat of a philosophical level, one of the things that we're trying to understand and really grappling with is this idea of complexity versus simplicity, right? So we've got unbelievably complex systems, and in general, I would argue or claim that complexity overall is not evil, right? It's not. Sometimes, like, complexity is necessary. The entire basis of cryptography is based on complexity, right? There's a lot of good that can come from cryptography, but the more complex our systems are, the harder it is to really observe what's going on. So you kind of got this thing that we're thinking about is like, okay, observability versus complexity. Like, what is necessary, what is essential, and versus what philosophically you would call essential characteristics versus accidental characteristics. And that's something that we're highly focused on. And that's, again, extends from both the technological side of things, but also the supply chain side of things. And it's, we've talked, many people mentioned on the panel already, just like how hard of a problem this is, right? We definitely don't want to, James was talking about going, some of the stuff that they do with electromechanical relays, and I wholeheartedly applaud that, because there has to be like a fail safe, and that's generally part of the CIE kind of mantra or thought process. But we also know all of the benefits that can be had from some of the more modern technologies. So yeah, I don't know that I have a specific answer for you, but other than we are very much thinking about this, like, what is this? Where is it important to simplify things as much as possible, and where is it okay to understand that complexity is actually part of a necessary?
And I would imagine across the life cycle of manufacturing, that's what gets so complex, correct?
Yeah, absolutely, right. So what we have is, and people have mentioned this, is that so our products are designed for 20 years, right? I mean, that's the design, and we replace them. We regularly get back things that are 30 plus years old, and if we can, if parts still exist, we will repair it and replace it for people. But how do you do that, right? I mean, a lot of these, like, really, really old systems they're obsolete, right? And so how do we make sure that we are allowing our end users to be able to not have to rip out kind of control systems every 5 years and upgrade them, because that's a really expensive, very long process, but maintain some sense of that they have semblance of security that's going to last, and then their partners, their vendors, are going to support them through that. So it's a hard problem.
Anyone else want to touch on manufacturing before we jump into the next set of questions?
Yeah, Frank, I'd like to weigh in here. The concept of supply chain is so difficult. I mean, how deep do you have to go in hardware, software, services to assure security? And that makes cyber-informed engineering and those concepts that much more important. So you're not fully dependent on any one of those deep dives into a vendor or manufacturer, but you're really trying to engineer, as Casey said, engineer it out and find ways that no matter what the device vulnerability we might stumble on, 5, 7, 10 years down the road, we can still be confident that that device is going to perform the function that we have designed it to, because of the way that we have engineered it. And I think that's an important component of CIE. But Nick also identified that, picking the right vendor and making sure that you have those relationships that you can count on from a vendor, that you're confident in their capabilities and their support to you, is critical these days in our world.
Awesome. No, and I just look back in recent history. sort of, I think it was Nick that touched on this and you did in a different kind of way, Jeff, sort of the rip and replace concept. I mean, to figure out dependency on Huawei, for example, or Kaspersky, and having to come up with very unique approaches to address it. I mean, these are big sorts of issues. So it's not only in engineering, it's an acquisition set of issues too, which I think demonstrates just how far-reaching some of these issues are. Anyone else want to touch on manufacturing? And if not, I want to sort of jump into the next set of questions around sort of, we talked standards and guidance, but before jumping to that, I want to make sure that no one wants to weigh in on manufacturing.
Yeah, Frank, this is James. I'd like to weigh in there as I think about the assets that we purchase and will continue to purchase. A great point in regards to a lot of these assets we keep in an environment for 15, 20 years. But it would be nice, to have a CIE stamp of approval on a device that we're about to deploy within an operational environment. And if what that means for us as an end user is that we are not spending engineer and technician time trying to dig into that box to understand where the software came from, and whether and do testing to validate that it is as secure as we need it to be. That may never be the case, but at least some type of idea that some thought has been put into engineering that device for security. And then along with that, not only the device being engineered for security, but we also have to take into consideration the environments in which these devices are being deployed. And so that's when you get into the electrical designs and the mechanical designs. And that environment, is a different approach. That same device may go into a solar field, or it may go over to a substation. And so as you think about that environment, up front, from the R&D through, from R&D, the conceptual through R&D to implementation, what are all those environmental considerations we need to take into account in regards to how these assets are being deployed. And so if I put a box around the energy sector, I think that is a way that we can truly partner together and think more intentionally about, that life cycle and that chain of custody, I'll call it.
Awesome. I'd be curious what others think about sort of a good housekeeping seal of CIE approval, or, I mean, clearly from an owner-operator perspective, that would be nice. And maybe we shouldn't treat this any differently than we do safety or some of the other sorts of issues. Anyone? We can use this as a segue to touch on that, as well as sort of standards and guidance, because Mark, I see you're jumping. So jump in.
Let me build just a little bit on what Nick had also said about complexity. Having a CIE seal of approval, I think it's a really cool idea, but we've talked about smart devices over the last decade or so, and things that are network aware and can talk to others. The big trend now is to go beyond smart, and we're including artificial intelligence, machine language, adaptive behaviors, a whole bunch of things now into these devices. And oftentimes the people who are ordering them, they're just going on price and function and does it do what the engineer specified. They don't really know what it's thinking or how it can adapt or what else can come inside that package. And so any type of seal or things, and we're leaning a little bit forward into this with SBOM, where we're going to try and describe, what's inside the package. Can we also describe what intelligence it has? And is there some way that an adversary might be able to adaptively change the way that component functions? This is all part of CIE, and it's part of what we have to have the entire engineering community begin to really embrace and understand, is that the actual components, the mechanisms of our infrastructures have gone beyond smart and into the next generation. And of course, there's going to be yet another wave even past that as we get even better at learning how to make these adaptive technologies. So that's also part of manufacturing, and certainly leads us to that very complex world that we're only getting the briefest glimpses of at the moment, but within the next several decades, we will be surrounded by complexity. The question is, can we manage it? And can we continue to understand it the way we understand linear systems today?
Glad you brought up the counterintelligence implications, because this has to be part of that thinking as well. So it really is far-reaching. Mark with the K, I see you want to jump in, so please.
Yeah, thanks. And Nick, I love that complexity is not evil statement. I love it. I'm going to steal that with attribution, of course. But I think that brings up a really good point, right? Some of these systems, I'm definitely a keep it simple, stupid type of person, but that's just not possible with some of these complex systems. It's just, they are complex because they are complex. And I think that really drives an important point that I think CIE really touches on, which is that not everything is the same, right? And we went through this process as a community before I was around, but on safety, right? Not every process has the same set of hazards. And so not every process needs the same levels of assurance. And that can, certainly, I love the conversation that we're having on supply chain. I think supply chain understanding, SBOM, great things moving forward. But it's also about, and James touched on this, it's about the implementation. The same device from Schweitzer can be in two different applications, one with significant potential safety or consequence, and one without, depending on how the system is overall designed, right? And so, Schweitzer is building a product to a standard that meets kind of both of those needs. Maybe we need to be thinking about different levels of assurance and levels of security as we bake this in and say, well, kind of like we do with safety, right? Our thresholds for safety instrumented systems are very, very different about how they function, how they're manufactured, how they're designed than, the thermostat, intelligent thermostat sits on my wall, right? There are very different applications with very different parameters. And I think that while I love a simple solution, I think that we should embrace those differences and really talk about, if someone hacks my thermostat, what can they actually do with that, right? And the answer is probably not much, right? It depends. That's always the right answer. It depends. But the answer is probably that much. But if it's a temperature sensor in a pressure vessel, that's a different scenario. And I think that if someone were to create a CIE stamp, seal of approval type of thing, we would definitely need some type of structure and stratuses of those and the different types of environments where it would appropriately apply and not apply. But I think it's a good goal.
Thanks, Mark. And I know Singapore is looking to implement something like this. So there is sort of a little bit of a case study to observe and watch and see. KC, you've been a little quiet. Anything you want to weigh in on manufacturing standards? And then we're going to go to education. So training.
Yeah, I want to pull sorry, Frank. I wanted to pull a string on what Mark said. I liked that idea around the engineering and, designing in the CIE piece. Really, we've been great at safety for a long time, especially in the electric industry. Every employee gets safety up here. We somehow got to shove security right under that. So they think safety, they think security, thought one, thought two. And then that's just standard. But really, what are we trying to do with CIE is get a system so that it's either trusted or trustworthy, and being able to understand that it's going to function within a certain set of parameters. And so how do we get those parameters to stay within a certain scope, right? Design in controls and engineering design that says, hey, you know what? Here are the base parameters. No matter what, it will never exceed these. So I can't with software move a decimal and impact a system, right? And, same thing on the hardware side. If the system is designed and built for safety protections, it has a criteria in which it operates, right? And defining those and then getting those standards rolled out into engineering standards beyond compliance checkboxes like we've talked about earlier.
Awesome. And really glad you brought up those points because I mean, it is about trust. Everything seems to hinge around trust, but it gets really hard when you get beyond device and even system level to systems of systems. And that's where sort of all the IoT and IIoT buzz becomes very real. And it's always one of these exercises as well. It's someone else is responsible to one extent or another. I'd be curious if we have some thoughts on how we can, because I think from the owner operator perspective, there are some opportunities there. And I want to use this because I know we have to be conscious of time to also jump in on. So when you look at CIE from an education standpoint, there is education, there's training, there's certification of engineers and operators. But here's the magic here. When I think of like cyber operations, we don't just need the ninjas or the cyber JSOC or special forces. This is everybody's responsibility. And when you look at engineering, it's not just making sure we have as many, and we need as many women and men, especially US citizens, involved in cybersecurity efforts, but it's also making sure that it finds its way in all engineering disciplines, whether it's mechanical, aerospace, EE, industrial, you name it. So I'd be curious what some of our thoughts are in terms of education, certification, and the like. So because we're kind of running out of time, I'm going to go in order of how we started. In 2 minutes input, Jeff, we'll start with you.
I mean, that's why part of the reason why we're here today is awareness and to really increase the adoption and possibilities for how institutions like McCrary and Auburn can really incorporate this into curriculum, and maybe places like SANS start offering a different view of their courses to engineers specifically that have a lot of these components of threat that is unique to that discipline. And I think it's a great idea. I mean, listen, we have a hard time recruiting anybody in cyber these days. There's just not enough people to go around. And this adds another component of another discipline that can think through difficult threats and vulnerabilities for our systems. And that just adds to our cyber workforce and really our security as a company and subsequently as a nation.
Jeff, I'm glad, and before Mark, you jump in, I'm really glad you brought that up because I mean, maybe we've been looking at the backfill the 700,000 unfilled jobs, which we need to do, but maybe that's not the right, maybe it's really to start integrating some of these other pieces that we don't necessarily need 700,000. I want them, don't get me wrong, but the flip side is maybe we've been thinking about this problem in too linear of a perspective. But and I'm speaking to engineers here, so sorry that I'm picking on linear thinking. But Mark with the K, why don't you weigh in here?
Yeah, I want to dovetail off of what Jeff just said because I think this is important. I think that, and don't get me wrong, I think it's important to continue to educate people who are experts in cybersecurity. I think we need a cyber safety domain by which we like teach the engineering principles and things like CIE into how we engineer for cyber safety. I think that's absolutely critical. But I think that we do that by getting into the industrial engineering programs, chemical engineering programs. It's not the cyber track people. It's not the computer science department that needs to handle this. It's the engineers need to have. They all need a flavor. And if you want to jump into it like you do with safety engineering, you jump into it, right? And then those people then become the ones that we look to design the cyber safety into the systems. And then we can actually start to pare back on how many people need to have that deep understanding, right? Because we're never going to get to a place where we're frolicking with millions of unicorns. It's not going to happen, right? So we need to take the human capital that we've got and apply it as effectively against the problem as we can. And that means some concentration. And again, I think CIE is a perfect concept of how do we get that engineered into the system so that the operator doesn't have to think too much about the cyber safety of their system. It's built right in, just like the safety system is. And if there's a problem with that, they've got the person to call at their organization or at their integrator to do that. And that's another thing we haven't talked at all about is integrators, right? Because if we're not targeting the integration community and those that are designing these systems, we're not going to get that fielded out to the asset owner operator community. But I think actually we need to focus it more versus try and hit 700,000.
Mark, well said. And you bring back a lot of your old work at CISA as well. You do have a cyber security review board now. You do have sort of JCDC. So there are different elements here because when you talk integrators, it's not just sectors and critical infrastructure sectors, which let's be serious, energy is at the very top of that list. But it's also critical functions, whether it's Windows or whether it's the cloud or whether it's PNT or you name it, that affect all of these sectors. KC, what sort of from your perch and how you make this happen at TVA?
Yeah, I mean, if you look at cybersecurity in the business, right, it touches everything. And I think Mark's point on building that education and that nomenclature of language. So, example, if I go around telling everybody, hey, you got to be cyber secure, they hear cyber, oh, that's somebody else's job. But if I just say secure, everybody kind of understands they have a role in it. And so we've got to kind of have that conversation and shift that language to people to, security and resilience is the priority, and then build that into the programs across, whatever educational line that designs and builds and implements, any critical function in lifeline sectors. So training and building that focus on the consequence and simplicity and layered defense, all those kind of things. But, it's really understanding how do we do that so that everybody gets it. And I think that's the idea, teaching people the idea of, kind of like we do phishing, teach them of an adversary thought process that, hey, bad people may want to use this in bad ways. And so how are you going to protect and prevent them against that? And just getting that conversation and building that into the broader scope of education so it becomes more cultural and basis of thought in all work and design. And, this may be my opinion, but CIE is kind of like, hey, what we should have been doing all along. So.
KC, well said. And in addition to altering and examining sort of education, nothing like scar tissue and experience, right? And this is where I think higher ed and all levels of education need to be working with the owners and operators and the product developers and designers. Otherwise, we're always going to be a little bit after the fact. So I just wanted to add, nothing like as the old saying goes, nothing like the smell of napalm in the morning. At the end of the day, nothing like real world experience to get things done. James?
Yes, Frank, to that point, leaning into KC's comments, the real world experience and the need to have that connection between what the needs are in the real world and those that are engineering and designing these systems. And we have to make this industry in this area that we're talking about, it's got to be cool. As I think about, the kids in high school and kids in college today, what is it that's cool about what we do? We need to tell that story more because these are great careers. You learn a ton, you meet great people. But more importantly, and I'll speak personally, this is mission critical work for the security of our nation. And if that can't get you motivated to dive into this conversation and be engaged, regardless of where you are, then we need to check your ticker because we all want our electricity on. We all want services that come through energy. And this is all in. Everybody needs to come together, working as a team to ensure that we accomplish what we're setting out forth here with CIE, which in turn supports this mission of safe and reliable energy delivery. And so I just really look forward to this continued conversation and engagement, across the board. And we don't know what we don't know. So there are things that I don't know about what each of you do that I can learn from. And so we all have to be open and transparent about opening up, listening, learning, and then applying. And I think CIE is a great vehicle for us to establish those partnerships.
Hey, James, I think you're super cool. So you got my vote, dude. So well said. And the reality is it has to cut across. So the mission critical owner operator is not just what we historically thought of in the national security community. It is all of critical infrastructure owner operators. So trying to open up that lens to be a little broader view, I think, is really important. So thank you for that, Mark, with a C.
Circle back to your original question about licensing and certification and so forth. I think most of us on this panel are licensed professional engineers, PEs. And this is the mark of achievement of all of us, so that amongst our peers and our employers, and in particular our customers, we are recognized as understanding the discipline that we're certified in or licensed in. For me, it's civil engineering, and inside of there, the principles and practices of civil engineering. When I took my exam many, many years ago, the word cyber was nowhere to be found. We thoroughly believed in safety. I think where we will go as the years unfold is that the principles and practices will begin to embrace cyber as one of the pieces, one of the disciplines inside of engineering. And in fact, as we license future engineers, we will be looking to see, are they competent in cyber? Are they able to take that on as part of the discipline of engineering? Again, we're not ready for that right now, but probably in the next 10 years or so, we're going to be able to get to a point where we will be. And I think that's an important role for us in the college and university world, is to begin to prepare these engineers for that and then work in partnership with manufacturers, with owner-operators, and others who are taking these graduates coming out of schools to make sure that we are indeed preparing them for what's needed. And not just to get the license, but also practically apply all these skills with a cyber bent to it. So that would be my big dream, is that we see cyber as part of the professional engineering community, recognized as such, and then becomes part of that exam process.
Well said, and I think it's a good dream, and I think the outcome, can't do engineering without cyber, is sort of, and vice versa, by the way. So well said. Nick, close us out.
Yeah, I think similar to what other folks have said is the idea that cybersecurity cuts across a lot of different aspects, right? So we've got cybersecurity is not just a box, right? It is not, that box is not cybersecurity. It is everything that went into designing, coding, manufacturing, installing, integrating, operating and maintaining that box. So everybody really has a role in that. And I think the more that we're able to teach that, just like to the safety idea, the better off we're going to be. Because I think the challenge with cyber is safety is a little bit more intuitive. Like if I touch this wire, like there's something very, very obvious that's going to happen, right? If I plug in this USB key, right, or this Cat5 cable, that's way more abstract for people to really kind of comprehend. So somehow we have to get across this aspect. And then I guess to finish it out, I would give a plug for the pillar that I'm the most interested in making sure that we develop is that development pillar, right? So we have cyber informed engineering. We don't have cyber engineering, right? Largely, and I think I wasn't involved in the naming of this, but I think the reason that is because engineering implies some sort of science that engineering is based on, and I don't know that we actually have the science fully developed to actually have cyber engineering. So now we've got cyber informed engineering. So until we get those basis principles, until we develop that core framework of fundamentals, I think that's we need to strive towards that. And I think that's where the MITREs, the national labs, all of the universities can really help us, like really concentrate on those fundamentals, understanding what they are, and educating our engineers and basically people across the industry to learn that. And then that just rolls in naturally to our design and development processes.
Hey, Nick, what a great way to close it out. I mean, you started talking philosophically, you ended very philosophically, and it really is an art and a science. And the reality is we don't know all of the answers, but we do know the outcomes. We do know this is important, and we do know there's some really good folks trying to make things work here. So thanks to all of you for a great discussion, and I wish we could go much longer, but unfortunately we're going to have to jump to the closing. So thanks to everyone, and let's make good things happen. So thank you.
Thanks all.
Well, thank you, everyone, and thanks for tuning in to hear more about a critical set of issues that so many are trying to make a reality. And we have an opportunity to hear from Charles McCrary, who is the namesake of my institute, and the reality embodies everything we discussed today. Former CEO of Alabama Power, a trustee at Auburn University, and brings all of the various ingredients we've discussed today into reality as a leader. So, Charles, you've got the final say. Thank you for spending some time with us today and closing us out. So over to you, sir.
Great. Thank you, Frank. And I really want to thank everyone who's a participant or in the audience today. Your time, your partnership, your collaboration is not only appreciated deeply, but it's also extremely necessary. Everyone on this call, whether you're a participant or in the audience, you know about cyber, and you know that cyber is involved in our everyday business and will continue to be involved in just about everything that we do. You know that, but I would submit that you are indeed the exception to the rule. Most people, I believe that most people think that cyber is kind of like fanning smoke. They really don't understand it, and they really don't think about it. And it is not that they're not smart enough, it's just not in their realm of expertise and not in their world. Even in engineering, in the engineering community, it's not unreasonable to think that the young men and women coming in as freshmen into the engineering or in some design world, they're just a microcosm of the public, and they probably don't think too much about it either. So, not everybody can be a cyber guru, but we've got to make sure that they're aware of the cyber issues and at least know the questions to ask. I heard today there's a deficit of 700,000 cyber-related jobs, and I'm reminded from an institutional standpoint, the goal is to prepare the faculty and the students as they enter new research opportunities or new career fields to prepare them to succeed. And I think it's up to Auburn, the government, other institutions, and business to own that challenge. Frank, bringing people together, educators and innovators with others in the frontline operators, I think that's the path forward. And I think today's event, Frank, is the first step in achieving the goal for a reliable and a secure infrastructure in the future. So I want to thank you and all the participants and everyone that joined in today. I appreciate your activity and your efforts.
Thank you, sir. War Eagle, let's make it happen. Thank you all.
Right.